Okay, guys, so yesterday, or so far with systems, we have been solving systems either by graphing, and then we learned how to solve a system without graphing using the substitution method. And today I'm going to teach you a third method called elimination that you can also use instead of substitution. The nice thing about solving systems is I'm giving you three different methods: graphing, substitution, and then today elimination. But you can use any method and you will still get the same answer. So I'm just giving you three different methods of doing the exact same thing and getting to the same result. So first let me define elimination method. It is also sometimes called linear combinations method. So just make sure that you know that elimination or if the instructions say linear combinations, they're actually the same thing, okay? There's just two different names for it. But it is a method for solving systems by adding the two equations together. That's why we call it linear combinations method, resulting in an equation with one variable, because when we combine the two linear equations, we will eliminate one of the variables. There are 5 steps. I know. So here we go. The first step, step 1, you first want to make sure that one of the variables in both equations only differ in sign. And I'll show you what I mean when we get there. But we want one of the variables to only differ in sign, meaning we want our variables to have the same coefficient, but one negative and one positive. Step 2, after you make sure you have that, you are going to add the equations straight down, which will eliminate one of the variables. Step 3, whatever answer you get, you're going to substitute it into one of the original equations. Which will help you solve for the remaining variable. And then always last, you're going to write your answer as an ordered pair. All right, so example 1. We have 5x minus 6y equals negative 32, and 3x plus 6y equals positive 48. So, if you guys notice, the first step in the steps that we wrote down is to make sure one of the variables in both equations only differ in sign. This is what I mean. Notice how in my first equation I have a negative 6y, and in my second equation I have a positive 6y. The y variables have the same coefficient, 6, but one is negative and one is positive. This is exactly what we want to happen, because look at what we're going to do. Step 2 was to add both of the equations straight down. So we're going to put a plus and our addition bar right underneath it, and we're going to combine these two linear equations. That's why this is called the linear combination method. Because look, what's 5x plus 3y? 8x. What's negative 6y plus 6y? 0y. So they eliminate. We had just eliminated the y's. Equals negative 32 plus 48. What does that give me? Positive 16. And now I just have x equals 16. I know. So in order to solve for x, I still have to divide by 8. We have to save the best for last, guys. We do the harder ones first, and then once we get to this, it's like cake, and it's all really, really easy. Don't make fun of me. So that gives me x equals, what's 16 divided by 8, guys?
Negative 2.
Positive 2. So, wait, we're not totally done yet because I just have x. I still need to solve for y, right? because my original equations have x and y in them. Because these are two lines, so we need an x comma y in order to find the intersection point. So here's what you get to do. You get to choose whichever equation you want. Do you want to do the second one? Okay, so let's plug in x equals 2 to the second equation. So that's 3 times 2 plus 6y equals 48. So we plug x equals 2 back into one of the original equations, and that gives you 6 plus 6y equals 48. Subtract 6. That gives me 6y equals 42, and then divide both sides by 6. So we get y equals 7. Oops. Okay, remember, you still have to write your answer as an ordered pair, so how do we write our answer? 2, 7. All right, guys, example 2. We have 4x plus 3y equals 24, and negative 3x minus y equals 2. I told you it was going to get a little harder. Why is this one not as easy as the previous one?
Because it doesn't have like the numbers.
Yes, because look at my coefficients. I have 4x and negative 3x, and 3y and negative 1y. Neither of these are the same but opposite signs yet, but we can make them that way. So this is ice cream cake. It's a little bit harder. Look at my 4x and negative 3y and my 3y and negative 1y. Which variable looks like it might be a little bit easier to eliminate?
The y.
The y's. Why? Because if I multiply the bottom equation by 3, watch what happens. 3 times negative 3x gives me negative 9x. 3 times negative y gives me negative 3y. And 3 times 2 gives me 6. Now, I'm just going to rewrite the first equation exactly the way it was so that we have them stacked. But now can I eliminate a variable? Yep. So if you're ever missing a term, multiply to get the same coefficients, because now I can add straight down. So what's 4x minus 9x?
Wait, hold on.
Negative 5x. Okay, so when I add straight down, 4x minus 9x gives me negative 5x. What about 3y minus 3y? Cancels, eliminates, equals 24 plus 6. 30.
Oh.
Okay, so we have negative 5x equals 30, so divide both sides by negative 5. And what do you guys get for x? Negative 6. Good. How would we solve for y? Plug it in. We can plug negative 6 into any of the equations that we've been working with. You will always get the same answer. Who wants to do the first one? Okay, who wants to do the second one? Just Jordan. Sorry, Jordan. We're going to do the first one, I guess. So that's going to be 4 times negative 6 plus 3y equals 24. But like I said, guys, it doesn't matter. You will get the same answer regardless. 4 times negative 26 is negative 24 plus 3y equals 24. Add 24. You get 3y equals 48. And then what?
You divide and
divide by 3, and we get y equals 16. So my answer is going to be negative 6, positive 16. All right, guys. Example 3. Negative 3x plus 10y equals 25, and 4x plus 40y equals 20. This is actually what Dana was asking about a second ago. So write it down, and then we'll take a look at it. Okay? So everybody look at it very carefully. Look at my x's. I have a negative 3x and a positive 4x. And then I have a positive 10y and a positive 40y. Looking at your x's and your y's, which one is going to be easier to get the same? The 10y and the 40y, right? But what do you notice about my signs? They're the same, they're not the opposite. So if I wanted to make that 10y into a negative 40y, what would I actually need to multiply by? A negative 4. Okay? So this is what Dana was asking, right? So what if the signs are the same and we want them to be opposite? You just multiply by a negative. So that's going to give me positive 12x minus 40y equals negative 100.
How do you get the negative 4?
Because I have a positive 40y and a positive 10y, but if we want to eliminate the y's, we need this to be a negative 40. So I multiply by negative 4. Yeah, so you just have to figure out what you want them to be, and then you multiply by whatever gives you that. Okay, so does that make sense, guys, how we made it to a negative 40? Yeah? So then I'm just going to rewrite the second equation. So that's going to be 4x plus 40y equals 20. So the second one we didn't have to change at all. So here's what I'm going to have you guys do. We set the whole thing up. In your groups, finish this problem. All right, guys, so when we add 12x and 4x, what did you get? 16x, negative 40y plus 40y. What happens? Eliminate or cancel. What about negative 100 plus 20? Negative 80. So then we divide by 16. And for those of you who just had to use a calculator, what'd you get? Negative 5. Yep. Okay, so then to solve for y, what do we need to do? Plug it in. How many of you plugged it into the first equation? How many of you plugged into the second? Okay, we'll go with the second since that's what a majority of you did. So that's going to give me, let's do the work this way. That's going to be 4 times negative 5 plus 40y equals 20. So that's negative 20 plus 40y equals 20. Add 20 to both sides. And that gives me 40y equals 40. So y equals what? 1.
This is a lot easier than the other one.
So, guys, how would you write your answer? Negative 5, comma, 1. Make sure you put the parentheses around it because that tells me that it's a point on a line. Okay, guys, example 4. This time, none of my coefficients match. I have 3x plus 5y equals 17, and 2x plus 3y equals 11. Okay. All right, so let's take a look at our variables, and we're going to decide together which one we want to eliminate. I already asked, and somebody already gave me an answer, what happens when the coefficients are the same? Jordan, can you explain it to us? Tell them exactly what you told me. No, before that.
You have to multiply both of them.
Yeah. So this time, because none of these are multiples of each other, we're going to end up multiplying both equations by something instead of just one. But the idea is the same. So let's look at the x's. We have a 3x and a 2x. If I wanted to eliminate the x's, what would I have to turn both of them into? A 6x, right? Look at your y's. I have a 5y and a 3y. What would I have to turn both of those into? A 15. It doesn't matter if we eliminate the x's or the y's, so let's take a vote. Who wants to turn the x's into 6's and eliminate those? Okay, who wants to turn the y's into 15's and eliminate those? Oh my gosh, it's like a tie. I know. Why don't we go with x's since we've been eliminating y's the whole time? So we'll go with the x's. So, to make my 3x into a 6x, what do I need to multiply by? 2. So multiply the whole equation by 2, and that's going to give me 6x plus 10y equals 17 times 2 gives me 34. I just know it. Yeah. Okay, now if we want the x's to eliminate, I already have a positive 6x, so what do I need to turn this x into? A negative 6x. So what do I need to multiply by? Good, a negative 3. So negative 3 times 2x gives me negative 6x. Negative 3 times positive 3y is negative 9y. This is going to work out nicely, guys. And negative 3 times 11 is negative 33. Okay. Add straight down. 6x minus 6x. Eliminate. 10y minus 9y. Y. Wasn't that nice? And 34 minus 33 gives us 1. Oh my gosh. Is there anything left to do for y's? No. So what do I need to do to solve for x? Plug it in. You can plug it into any of the equations. So who wants to plug it into the first? You guys, who wants to plug it into the second? Okay, Moore said the second. So that's 2 times x plus 3 times 1 equals 11. So 2x plus 3 equals 11 minus 3. So that gives me 2x equals 8. And divide by 2. So we get x equals 4. So my answer is 4, 1. Okay, so example 5, we have decimals. So the first thing you always want to do is get rid of them. So we're going to move the decimals over one place on everything, which is actually multiplying by what, guys? Good, by 10. So that's going to give me 1x minus 8y equals 18. Thumbs up if you got that. Perfect. And then 2x minus 16y equals 8. Yes? Okay. Now, take a look at your x's and your y's. Which one might be easier for us to eliminate? The x's, and we would have to multiply the first equation by what? Caleb says negative 2, Tatiana says positive 2. Nope, she changed it, it's negative 2. Okay, so that's going to give me negative 2x. Negative 2 times negative 8 is going to give me positive 16y equals negative. 18 times 2 is negative 36. And then this one stays the same. So 2x minus 16y equals 8. Yeah, we only have to multiply, because we decided to eliminate the x's, we don't have to multiply the bottom one because we already get opposite coefficients. Okay? Yes, every variable always has a coefficient. Okay. Okay, I know where you're getting at. Okay, guys, what's negative 2x plus 2x? 0. It eliminates, right? And what's 16y minus 16y? It also eliminates. So what am I left with on the left-hand side? No, hold on. On the left, everything eliminated. So what do we have? What am I left with on the right? Negative 20? 20? 24, right? 28. I know. I'm just double checking. Does 0 equal negative 28? No. So, no solution. So example 6. Yes. So example 6, I have 6 over 8x plus 2 over 4y equals negative 6 over 8. And 4 over 5x plus 4 over 5y equals 4 over 5. Let's get rid of those fractions. Yeah? Okay, so looking at the first equation, I actually have different denominators this time, so everybody pay attention. My denominators are 8, 4, and 8. Which number will eliminate all of my denominators? 8. If I multiply by 4, we are still left with a 2, right? So you have to multiply by the biggest common denominator, okay? So multiply the entire first equation by 8 over 1. And watch what happens, so pay attention. 8 over 1 times 6 over 8. What happens with those 8s? They cancel and we're left with 6x. Now, no, that's not all. 8 over 1 times 2 over 4. 4 goes into 8 how many times? 2 times. So we're left with 2 times 2, which gives me 4y. So make sure that you're paying attention if it eliminates all the way or not, okay? So I just wrote a 2 right here to remind myself to multiply them, okay? 8 over 1 times negative 6 over 8 comes out to negative 6. Good. Now, thank goodness, the bottom one is all the same denominator, so what am I going to multiply by? 5 over 1. So that's going to give me 4x plus 4y equals 4. Okay. Do I have, what variable are we going to eliminate here? The y's, but my operations, my signs are not opposite. So what do I need to multiply one of them by? A negative. Who wants to multiply the top by the negative? Bottom? Okay. So if I multiply the bottom by a negative, negative 1, right? That's going to give me 6x plus 4y equals negative 6. The top one doesn't change. And then multiplying the bottom by a negative just changes all of the signs. So negative 1 times 4x is minus 4x. Negative 1 times 4y is minus 4y. And negative 1 times 4 is minus 4. Yeah? Okay. Is everybody with me so far? Okay. So when we add straight down, I have 6x minus 4x. What's that give me? 2x. 4y minus 4y eliminates. And negative 6 minus 4 gives me negative, no, 10, negative 10. Yeah, because both signs are negative. Because negative 6 and negative 4. Divide both sides by 2, and I get x equals what? Negative 5. Okay, who wants to plug negative 5 into one of these ones with the fractions? I wouldn't either. Let's go with one of these non-fraction equations. Second one? Okay, so that's 4 times negative 5 plus 4y equals 4. So that's negative 20 plus 4y equals 4. Add 20. So 4y equals 24. And then divide both sides by 4, and you get y equals 6. So our answer is negative 5, comma 6. Make sure you put it in parentheses. Okay, guys, because it's winter, we're going to the ski resort.
Really?
Yeah. Let It Snow Ski Resort offers two winter specials. 2 winter specials, the Getaway Special and the Extended Stay Special. The Getaway Special offers, and here's what I want you to write down, 2 nights of lodging and 4 meals for $270. The extended stay, oh my gosh, this thing is riddled with typos. The extended stay special, there we go, offers, and here's what you need to write, 3 nights of lodging and 8 meals for $435. 7. And then I want to know how much does each night and each meal cost. All right, guys, let's write this as a system. The Getaway Special offers 2 nights and 4 meals. So what? How would we write that? 2 what? Do you guys want to use X?
Yeah.
Not N? Let's use N. 2 nights and 4 meals. So plus 4M equals $270. So how would we write the extended stay special? 3N plus 8M equals $470. 35. And then we would use elimination to solve, yes? Okay, so which variable do you guys want to eliminate? Do you want to eliminate the n's or the m's?
M.
Why m? Yeah, because we would only have to multiply the first equation, right? What do we need to multiply the first equation by? -2. So multiply the first one by -2. And that gives me -4n minus 8m equals -540. And then do we have to change the second equation at all? No. So that's going to be 3n plus 8m equals 435. I'm going to have you guys finish it. So with your groups, finish the problem. Okay, so when I add straight down, -4n plus 3n, that gives me what? -1n. -8m plus 8m eliminates. And what do you get for -540 plus 435? 105. So if I have -n equals -105, positive n would equal what? Positive 105 what? Dollars. So make sure you put the dollars. Now, because this is a word problem, and we're talking about dollars, you can leave your variables separate. So in the word problems, you do not have to put your answer in an ordered pair, because we're talking about dollars, and with the ordered pairs, we don't put dollars, right? So you can just leave it as n equals 105. But I still need to solve for m. So which equation did you plug n back into? The first one. So this is going to be 2 times 105 plus 4m equals 270. 2 times 105 gives me 210, yes? Okay, plus 4m equals 270. Subtract 210. So I'm left with 4m equals 60. So what does m equal? 15 what? Dollars. So those better be some good meals. So each night costs you $105, and each meal were to cost you $15 if you were to pay for each one separately.
Wait, so would it be